Hello and welcome to my lecture review for the textbook, Internet and Web Application Security, 3rd edition. This is done by Jones and Bartlett Learning. Again, copyright, they own everything. This is their book. I'm using their PowerPoints. I'm just providing video lectures for my courses that are using their official book. The assumption is you own the book and you are in one of my assigned courses. The book ISBN number 9781284206166. Again, copyright for the Internet and Web Application Security 3rd edition by Jones and Bartlett Learning is owned and maintained by them. These are just video lectures on their official PowerPoints, so let's jump on in. Mitigating Web Application Vulnerabilities. This will be Chapter 9. So, identifying and mitigating web-related risks, threats, and vulnerabilities. We're looking at key concepts, web app vulnerabilities, and mitigation, because sometimes when we're looking at risk, we have to kind of understand how we can mitigate those risks. And keep in mind, sometimes we transfer the risk, sometimes we mitigate the risk, sometimes we accept the risk. So don't get into the habit of looking at risk always as mitigation. Though the goal typically is mitigation, but if it's too unrealistic, sometimes companies will just accept a certain level of risk. We'll be looking at secure code best practices and how to incorporate HTML and JavaScript secure coding standards and techniques into our process. Alright, so as we move past that, we're also looking at how to incorporate CGIs from SQL database access for secure coding, separating the front end and the back end. That also looks at input verification, input sanitation. We're going to be looking at implementing software development configuration management and revision level tracking. That way we are not just doing things willy-nilly, but everything actually has a management lifecycle. We're going to be looking at best practices for mitigating web app vulnerabilities. So let's go ahead and jump right on in. So hackers typically look at the source code of a website to better understand the structure and so that they know how to attack it. Basic reconnaissance for the hacking framework is look at your target, analyze your target, and figure out the best multiple ways in. And if we're looking at something public facing, looking at the code, the source code, looking at how the app or web app actually processes user input, all of those are great ways to see if that's an actual entrance into a target. 3 areas that normally hackers are looking at is input validation, some form of session management. Are they cookies? Are they tokens? Can we steal them? And authentication. Input validation, because even if you have a static site, typically there's some input component, a search, a login. Maybe not even a login, but typically at least a search. So are we able to put some code there, or are we able to inject some code in an input box to see if we get inappropriate responses? And again, companies large and small fall victim to this pretty regularly. Uber, pre-COVID, had this issue where it's now been fixed, but if you did a injection attack on their website, you could get a list of all their drivers. It was identified, it's now been fixed and patched, but large companies fall victim to this. Amazon and Google spend a lot of money on bug bounties to make sure that companies and people test their security on a regular basis, so that these 3 main areas are heavily tested and mitigated. Cause of web app vulnerabilities, specifically looking at the authentication. A lot of companies have web apps failure to provide strong authentication for end users. The main target here is escalation of privileges, accidental disclosure of confidential information, like socials or tax data, data tampering. That's a big one. I worked for a payday loan company, and we had a breach in our database, and they tampered with the payday loans, like 100 different loans out of like the 20,000 we had processing. And so we didn't know who the attacker was because it was one of the 100, but all of it was written off to the insurance. But the important part there is it literally was we could not trust the data in our database. And so data tampering is a huge issue for authentication. And then lastly, some form of luring attack. And again, these are not an exhaustive list. These are just some of the common ones. Again, the big one that I would focus on is escalation of privileges, because if you're able to target and gain access with a standard user, you might be able to escalate your privileges to something stronger and be able to do more damage. As we move past that is input validation. Non-validated or poorly validated inputs are a huge threat. If malicious users can discover an app that makes assumptions about the length, the types, the formats, the range, you can manipulate it. If I have an input box where it says log in and I'm expecting an email, then I should have some type of validation that says something at something dot something. The typical standard structure of an email. Something at a domain dot something. If you're allowed to put anything, then you could be subject to an injection attack. Or maybe you have the ability to upload an avatar or upload a photo. Well, you can upload an XSS attack instead of an avatar. That way, when something loads your avatar photo, it actually does launch an XSS attack. Which again, less common nowadays because HTML5 and basic OWASP kind of has pointed these out as major attacks, so that a lot of common large companies have mitigated these. But if you're dealing with small companies, that's still a option. Big issue here is always look at your input areas and ensure that there's some form of validation there to prevent injection-based attacks. Session management, again, whether it's a cookie, whether it's a token, you have to have some type of system to handle and manage sessions, typically in a secured environment, which will require some type of session security. That way, you are not subject to the threats of like session hijacking or replays. Or, the more dangerous one is an on-path attack, formerly known as man-in-the-middle. A session hijack, basically, it will exploit a valid session to gain unauthorized access to information. Session replay is where a web app will take a user token or session that's intercepted and will use that token to bypass the authentication controls, because at one point it was a valid token. You can do delays, you can do timers. There's a lot of security measures that you can put in place to prevent these more common attacks. And again, they've been around 20 plus years, 25 plus years. So there are mitigation strategies to prevent all of these. It's just a matter of, are you paying attention? So non-secure coding applications, some common ones are XSS attacks, SQL injections, or just injections. Failure to preserve OS command structure. Can I escalate from a web portal? Can I escalate to the web server's home directory? Can I break out of the web hosting directory and gain access to the back-end operating system? And typically that would be a operating system command injection attack. You can also see if you can inject or redirect untrusted data to malicious sites. This is known as an open redirect. If the site is using older technology, can you have improper control of file names? So you can do PHP file inclusion by manipulating some of the files. typically a PHP file, but PHP is not the only one, it's just one of the more larger common ones. You can look for improper check for unusual or exceptional conditions. That's part of OWASP. You can start targeting and manipulating variables on a web server to see how it reacts and to see if you can escalate what you're capable of doing. You can incorrect a calculation for a buffer size and overload a server's for a buffer overflow exploit. You can download code without integrity checking. You should be able to use a hard-coded. You should be able to prevent the use of hard-coded credentials. You should be able to use authentication prompts. That way, any calls are done correctly and not listing hard-coded credentials. Sadly, there are websites out there that still have hard-coded credentials and make them way easier to exploit. Lastly is the use of broken or risky cryptography algorithms, i.e. old crypto systems that are easier to break yet are still out there in use. Again, you want to avoid all of these. These are all pretty common and on the OWASP top 10 that you should be mitigating against. So what you want to be focusing on is developing policies to mitigate these vulnerabilities. Normally, if you have a security policy, they should address things like like prevention of all of these. You should also be able to address data security and storage and transit, asset inventory and management, end-user security, physical security, access control mechanisms, incident management, reporting, collection. There should be some form of fault tolerance measurements and measures in place, and there should be some form of non-compliance consequences for internal organization groups. Now, the organization may also face non-compliant consequences if they're not held to standards as well, so we do have to keep that in mind. Non-compliance consequences are both internal and external depending on your industry. When developing the policies, you need to know, what are your assets? What are you trying to protect? To what degree are you trying to protect them? What are the common vulnerabilities and threats? What are the mitigation strategies for the assets in question? When should security policies be reviewed, updated, analyzed, viewed for completeness, tested to see if they're truly mitigating what we thought they were mitigating? They should also include authentication policies, access privilege policies, disclosure of confidential data policies, incident response policies, planning, record keeping, retention policies, things like that. So a sample policy will have things like purpose. The data confidential policy is designed to help network users identify what constitutes sensitive data and the data that cannot be disclosed. Again, a generalized statement. 2 will be scope. That will be the data and how it's categorized into whatever categorizations that you may need. In this example, we have 2, public and confidential. As we move past that, we'll have a policy that actually looks at the scope and we then define them. So the confidentiality policy will outline the procedure for protecting the information at the various levels. So for public data description, who's allowed to view it, how are we supposed to handle it? If we only have 2 in our scope, then we'll only have 2 main subsections here. 1 for the first scope, 1 for the second scope. So you'll notice 3.1 is public, 3.2 is confidential. That's because in our scope we only listed those 2. And then we would drill down deeper. Again, this is an example, not an overall arching approach. The development of a data confidentiality policy is way more in-depth. Implementing secure code best practices. There are secure code guidelines. CERT lists these top 10 tips for secure coding. You'll notice input validation, number 1. Heed compiler warnings. Plan and design for security policies. Plan for security from the start in the life cycle. Keep the coding simple. Deny access by default. Again, typically a zero trust approach. We do want to use the principle of least privilege, only give people or only give systems what they need to do their bare minimum of their job. Sanitize data in and data out. Sanitize data sent to other systems. Use layered protection. You're not limited to a single layer. Use effective quality assurance techniques. Test your code, essentially. Adopt a secure coding standard and work through it regularly. There are language-specific ones, so incorporating HTML secure coding, for example. HTML is one of the more widely used languages for web docs, so developing a strategy here could be very useful. General guidelines can be used to help ensure HTML code is deployed and secured correctly, like encrypting HTML code, keeping the code clean, monitoring it, again, input validation and validate the URLs, and again, no hard code credentials. You could also do the same thing with JavaScript. There are code standards to ensure a certain level of security. JavaScript has a unique set of security challenges, so when you're designing an app using JavaScript, you need to keep those security challenges in mind. Look for secure environments for executing mobile code. Test, verify, and check. Don't assume. When JavaScript architecture was designed to protect systems and users from hostile programs and downloads over a network, but you cannot defend against bugs in the code. So can open holes in the platform. You just have to, again, thoroughly check it. Incorporate JavaScript is not a one and done. Typically, you're looking through life cycles, so you verify it, and you may approve it, and then you have to do a regular review to ensure that we're still mitigating the threats we identified. And then we may need to review it for additional threats. So the fundamental aspects of secure coding standards with Java, again, prefer to have obviously no flaws, keep code simple, avoid duplication, restrict privileges, least privileges possible, look at trusted boundaries, avoid dynamic SQL, avoid injection capabilities, any type of input you're validating and sanitizing, look at XML and HTML generation. You need to look at these with care. Take care of interpreting untrusted code. You need to ensure a certain level of trust is here. If we're looking at CGI and SQL database access, while CGI is not a programming language, it is a standard that enables communication between the web forms and the programs. Web form data is often saved in the backend database, so there is going to be some connection here. Strategies and techniques used to protect the server and backend are, again, limit user access, validate input, limit error messages, log and audit access, encrypt items, again, validate and sanitize inputs, restrict physical access to the database server, and use strong authentication. You're going to notice the common theme. Input validation. You want to keep things simple, encrypted, and log everything. Lastly, authentication controls. Those are the big reoccurring themes that are just going to be over and over and over. We do have a revision tracking management guidelines. Software configuration management, SCM, is the mechanism used to track and control changes in software. The main advantage is you keep record. So you prevent unauthorized changes, you have greater control, ease of management, better quality control. You get to know what's going on with the code. Right there, that alone is worth it. Revision level tracking is a management of change to documents, programs, anything, so that information stored or information modified or code changed can be readily reviewed. Hey, this is happening that wasn't happening in a previous version. What was modified? That is what revision level tracking allows us to do. The process is most commonly used in the software development lifecycle, and it's normally done with a team. Each revision is associated with a timestamp and is identified by whom or what's making the change. In coding, revision tracking is any process that provides control over the change of the code. Best practices for mitigating web app vulnerabilities: train the software people. Incorporate security at all levels. Incorporate testing standards. Monitor threats, vulnerabilities, and look at risk. Develop security policies and practices from the beginning. Maybe have a security person work with the developers. Restrict access to those who need it. Ensure error messages are handled, and if there are any error messages being prompted to the end user, you want to limit what information is actually shared. You really don't want error messages given to end users, but if there are, you want to sanitize them the best you can. Provide basic hardening systems and harden the application. Verify app config. Again, validate inputs, validate authentication mechanisms, validate encryption, and ensure secure communication. Alright, that was the end of this chapter. Questions, thoughts, or concerns, please let me know. Thank you. Alright, that concludes this video lecture for this chapter. If there's any questions, thoughts, concerns, or issues, please don't hesitate. Feel free to reach out. Thank you.